Hi everyone, let's begin one more complicated problem related to t-test. Question is, a manufacturer claims average life of a battery is 102.5 hours. To test the assumption, a sample of 25 batteries was taken. Average life of batteries in the sample was measured to be 107 hours. With sample standard deviation of 10 hours, test the hypothesis at an alpha of 0.05. So, what has been given in this question? You can see here, this is our population mean 102.5 hours. That means this company, those are manufacturing these batteries, they are saying our average battery's average life is 102.5 hours. So, that means we can call it mu. Mu, it is our population mean. To test the hypothesis, a sample of 25 batteries. This is our sample size, means N. N is already given 25. And average life of batteries in this sample was measured to be 107 hours. That means X bar. This is the sample mean. 107 is sample mean. So with sample standard deviation of 10 hours, standard deviation would be 10 hours. Sigma is 10 hours and test the hypothesis at an alpha of 0.05. That means at the 95% confidence interval, we are testing. So null hypothesis would be there is mu would be 102.5 5 hours. That is already written here. And H1 would be mu is not equal to 10.5 hours. Right. So which formula we are going to apply t-test? T-test. Here is you can see x bar minus mu divided by s divided by under root n. So all these things has been given in this problem statement. Simply we are going to apply, and after that we are going to test whether which hypothesis would be accepted, which one is rejected. So let me calculate. This is my formula through which we had calculated. Let me take my pen, and you can see here x bar, this would be x bar and minus mu s divided by under root n. So x bar is already given 107, mu is 102.5, 10 is our standard deviation and under root n, that means it's 25. So ultimately when we have to calculate solve this, so 4.5 is our difference in between x bar and mu, and 10 divided by 5, further we have to solve it. So final t observed value, or we can call it t calculated value, is 2.25. Let me check what is the value, table value at this 0.05, and when we have to calculate degree of freedom. So degree of freedom, because total sample is 25, so degree of freedom formula, as we know, n minus 1. That would be n minus 1, n minus 1. So n minus 1, that would be 24. So at 24 degree of freedom, we have to calculate critical value. So critical value we have find out through our table 2.064. So 2.064, let me check through my one table. This is my table. You can see here, this is the 24, and we want to check at the 0.05. Yes, this is my value. This is my value. So 2.064, this is my table value, because at degree of freedom 24. So two tail, we are going to check two tail. You can see here two tail. You can see here, this is two tail, right? 0.05. So finally, you can see this value 2.064. This is my table value and this is my observed value, or we can call it calculated value. Observed value, it is greater than this value. So how we are going to interpret this result? Calculated value, we will write calculated value is greater than critical value. That is 2.25. That is greater than 2.064. So null hypothesis is rejected and alternate hypothesis is accepted. So it means, what do you mean by this statement? Null hypothesis is rejected and alternate hypothesis is accepted. It means this manufacturing company, whatever they were claiming our our manufactured battery average life is 102.5 hours. That is not true. So we are rejecting this null hypothesis. That means there is variation. So alternate hypothesis said mu is not equal to 102.5. And that is actually reflecting in this problem solution. And finally, we can say null hypothesis is rejected and alternate hypothesis is accepted. I hope this video would be helpful. Keep watching. Stay tuned.